Salt, and more specifically sodium chloride, has been very important for a very long time. Salt, among other spices, used to be extremely expensive, which is humorous when considering that nowadays we dump it on the road to melt snow. Salt, at least as a preservative, was proven less useful when refrigerants were introduced, and thus prices decreased. Compounding with the modern ease of travel and transportation, it's a much less valuable commodity. Having done everything practical to prepare themselves for the journey, they prepared themselves to meet death, which is always on a sailor's horizon. Methods of producing salts involve evaporation of water, evaporating of brine springs, and the mining of salt rock or halite. The boiling of seawater is the most common in coastal regions, whereas the mining of halite is more common in landlocked or arid regions. The method of collecting seawater involves digging what are called pans to collect water when the tide comes in, to where it will evaporate when the water recedes, like this. Salt resulted in one of the great trade triangles. For centuries, the Saharan desert was barrier to trade for the North African region and those in the south. There are great deposits of halite in the Saharan desert, which is fortunate for the northern Africans because the southern Africans don't have any and they need it. In the 8th century, Berber merchants from North Africa started trading salt for grains, dried fruit, textiles, and tools. Salt was actually so abundant in the northern part of Africa that workers in the mines built their houses out of it, as did those who came to profit off the local mining industry. The fourth region in this triangle was Timbuktu. In the 4th century, Timbuktu had become a major trading post, and consequently converted to Islam due to the Berber merchants. For salt, they traded slaves, ivory, and even gold. The exit route for this trade triangle is the northern region of Africa near Morocco, where they traded with Europe. Europe often used salt as a preservative as opposed to drying or smoking, as these could not be used at sea, because it's wet on the ocean, and you wouldn't want to burn your boat down. The Europeans traded fish, including herring, cod, and haddock. Since there was so much halite being traded, England, France, Holland, Spain, and others decided to start mass fishing operations where the fish they caught were cut and cleaned at sea. These particular species were overfished for centuries until a moratorium was introduced by Canada in 1992, which was then adopted by most other countries. Many wars and battles were waged over land that was rich in salt. The area surrounding the Dead Sea was repeatedly conquered for their salt. Venice frequently attacked those who threatened their European monopoly. America experienced a salt shortage when an embargo was placed on them during the Revolutionary War. Napoleon's retreat from Russia was poorly supplied with salt. Thus, salt deficiency hindered the healing of wounds, as well as the fact that a lack of absorbic acid caused scurvy among the troops, resulted in an even larger loss of lives than invading Russia during winter always brings. Sodium chloride conducts electricity in a solution and has a solubility ratio of 36 moles to 100 moles of water. In 1887, Swedish chemist Svante August Arrhenius first proposed the concept of positively and negatively charged particles as a cause for salt's chemical behavior. He said that ions, also explained why acids, despite having a different atomic structure, behave similarly, and that the H+ ion accounted for their sour taste. For his findings, he was awarded a Nobel Prize in 1903 as the scientific community took a little convincing. Though it was first proposed in 1833, British physicist Joseph Thomson is the first to demonstrate that all atoms have electrons, and that electrons are negatively charged subatomic particles, and that by removing them from a particle it became positive, while adding them resulted in a negatively charged particle. What accounts for the solubility of salt is that the attraction between ions in salt is less than that of the attraction between ions in water, giving it the ability to disperse randomly. Because water is partially charged at each end, it is attracted to the negative chloride ions like this, and the positive sodium ions like this. Because salt attracts water like this, it absorbs moisture out of food, which is the property that makes it a preservative. In regards to the body's need for salt, authors Penny Le Couteur and J. Burreson had this to say. Part of the process that generates the electrical impulse transmitted along neurons in the nervous system involves what is called a sodium-potassium pump. More sodium ions are forced out of the cell than potassium ions are pumped into it, resulting in a negative charge of the cytoplasm inside the cell compared with the outside of the cell membrane. Thus, a difference in charge, known as membrane potential, is generated, which powers electrical impulses. Salt is therefore vital for the functioning of nerves and ultimately muscle movement. Cardiac glycolysis muscles such as the digoxin and the digitoxin found in foxglove inhibit sodium-potassium pump, giving a higher level of sodium ions inside the cell. This ultimately increases the contractive force of the heart muscles and accounts for the activity of these molecules as heart stimulants. The chloride ion from salt is also needed in the body to produce hydrochloric acid, an essential component of digestive juices in the stomach. There is a very fine line between the correct amount of salt, too much salt, and not enough. The impact of salt deprivation includes loss of weight, cramps, nausea, and inertia. In extreme cases, it leads to cardiovascular collapse. Excess sodium leads to high blood pressure, kidney failure, and liver failure. Nutritionally, we need salt. Since meat contains salt, carnivores need less supplementary salt than do vegetarians or herbivores. Salt was needed in order to chemically manufacture soda ash or sodium carbonate, which is used for making soap. The artificial manufacturing of sodium carbonate is important as natural deposits are limited, occurring around dying alkali lakes or from burning kelp or other saltwater plants. The original method was discovered by Archibald Cochrane, the 9th Earl of Dundonald, but it was not a commercial success in 1790. 1 year later, however, Frenchman Nicolas Leblanc came up with a new method using salt, sulfuric acid, coal, and limestone. Unfortunately, he was also not met with commercial success due to some sort of revolution or something. Those clever Brits just up the English Channel, however, used this process and were the first to make a profit on it, which is a shame because the French could have really used that soap. In 1860, Belgian brothers Ernest and Alfred Solvay developed an improved method of converting salt into sodium carbonate, which is the process we use today. Using these compounds, we create sodium bicarbonate and ammonium chloride. From there, one simply heats up the sodium bicarbonate to get sodium carbonate and carbon dioxide. But nobody cares about CO2, so they just let it float off.
I'm free!
Lastly, sodium is used to make another compound. Sodium hydroxide is made by passing electricity through a sodium chloride solution, in a process known as electrolysis. It's among the most manufactured chemicals in the US and is used to extract aluminum from its ore and manufacture rayon, cellophane, soaps, detergents, petroleum products, paper, and pulp. It also produces chlorine, and although originally considered a waste, was soon used as a disinfectant, bleaching agent, and a delicious drink. Salt has many uses from nutrition to manufacturing to flavoring, and is undoubtedly a very important compound that has influenced much of history.